Hey everybody, in this video I'm going to go over Newton's first law. So I'm going to go over Newton's first law by talking about if we could imagine a situation, right? So I want you to imagine a situation where you are sitting on a bus. When the bus starts moving. And when the bus starts moving, you notice your backpack, which is on the floor, slides backwards. Your friend is watching from the bus stop. Okay, so let's think about this scenario of what's happening to that backpack from two perspectives. We're going to look at it from your perspective on the bus and from your friend's perspective outside of the bus. So let's start with your perspective. On the bus. Okay, so if you are on the bus, here's the bus, here's you. And it looks like to you, all of a sudden, your backpack slides towards you, right? So if I'm going to draw a motion diagram to represent the backpack, we're going to see that it's all of a sudden starts accelerating backwards. So I'm drawing my dots as having increasing space between them. I'm making sure I have a zero, positive, and negative, and I'm doing a change in velocity to the positive direction. Okay, and that's to show us that this backpack just starts moving out of nowhere to that positive direction. Okay, now let's draw a force diagram to represent this backpack. Okay, so we know there's always the force the earth exerts on the backpack. Force earth on backpack. And we know there's the floor. So I'm drawing an arrow up. Force floor on backpack. But looking at this scenario, I don't see any object that is making the backpack move towards the back of the bus. So I'm not adding any arrow here for that horizontal direction. So now if we look at this, we see that our change in velocity is to the right, but our sum of the forces is zero. So this is not consistent. We saw previously that the sum of the forces and the change in velocity have to be in the same direction. So something's going on here that's making this not consistent. We're going to circle back to that, but let's look at the perspective of this from your friend who's on the bus stop outside the bus. So friend perspective on bus stop. Okay, so outside the bus. So your friend is outside the bus and they see you on the bus with your backpack, okay? But what your friend sees is that the bus is moving forward and the backpack stays still. So it's almost like the bus is moving around the backpack and that backpack is staying still. So if your friend were to make a motion diagram, they would say, well, that backpack's not moving, so I'm just drawing one dot, putting my zero, my positive and negative, and my change in velocity is zero. Then your friend would make a force diagram, and it would be very similar, right? We'd see the force the earth exerts always on backpack. And it's balanced by the force the floor exerts on the backpack. And your friend is seeing, well, there's no object pushing it in the horizontal direction. And that makes sense because it's not moving. So here, your friend says the change in velocity is zero and the sum of the forces is also zero. So your friend sees this as consistent, okay? So looking back here, given this one scenario, two different observers can have a totally different experience, right? From your perspective, it looked like that backpack moved out of nowhere. Nothing was pushing it, and it just started moving. And so your force diagram and your motion diagram were not consistent. But your friend who's on the bus stop can see what's really happening is that backpack's not moving. It's just that the bus is moving with you in it, and the backpack is staying in place. So they see that that motion diagram and that force diagram are consistent. And the reason why we have different things is because of our reference frames. So the person who's on the bus, you being on the bus, you are in a non-inertial reference frame. We know it's non-inertial because it is moving. And for non-inertial reference frames, they don't always see that the sum of the forces and the change in velocity are consistent because they're in that non-inertial reference frame. But your friend is in an inertial reference frame. We know that because they are not moving. And they see that the sum of the forces and the change in velocity are in the same direction, right? They're both zero. So this brings us to Newton's first law, okay? So I'm going to write it out and then we're going to explain. So Newton's first law, okay? What we see in Newton's first law is that to an observer in an inertial reference frame, an object will continue moving with a constant velocity unless an unbalanced force, or some of the forces, is exerted on it, okay? So, again, I want to really point out, it's for an observer in an inertial reference frame, right? For an observer in an inertial reference frame only, an object will continue moving at a constant velocity unless an unbalanced force is exerted on it, okay? So, constant velocity could mean there's one situation where it could be the velocity is zero, so it's going to stay still. It's going to not move unless an unbalanced force is exerted on it. Or you could have a velocity not equal to zero, so it's going to continue moving at a constant velocity. Okay? So what Newton's first law is saying is that an object's going to keep doing what it was doing. If it's moving, it's going to continue moving with that constant velocity. If it's still, it's going to keep staying still unless an unbalanced force is exerted on it. But this is only true for an observer and an inertial reference frame. And for an observer in an inertial reference frame, we should see that the change in velocity and the sum of the forces are consistent. And they should also be in a not moving place, okay? A non-inertial reference frame, they are going to see that this is not consistent, that the sum of the forces and the change velocity might be in different direction. And that's because they're in a moving or non-inertial reference frame. So the key ideas here about Newton's first law that I want you to know is that what it's saying is that object's going to keep doing that same motion, either staying still or moving with a constant velocity, unless the sum of the forces is exerted on it. But I also want you to understand this inertial reference frame part, that Newton's first law only holds true for observers that are seeing this from an inertial or non-moving reference frame. For observers that are in a non-inertial reference frame, a moving reference frame, they are not going to observe Newton's first law. Hopefully that helped explain Newton's first law to you. If you have any questions, please email me or message me through Remind.